Hello and welcome back. So far we've talked a lot about different data storage system, databases, electronic lab notebooks and so on. And the best way to get familiar with all of that is to build a little project on research data management yourself. So we'll introduce now our final project for this course, Introduction to Research Data Management. So the project idea is that you build your own very simple RDM system. It's probably not what you want to use in production later on, but it can serve as a basis for it. And even if you're going to use a much more elaborate system from some other provider in the future, building a very small RDM system yourself will get you more of a feel of all the choices that we need to make and put everything into practice that we've discussed in this course. There is a code repository as a companion where I've added a few examples and companion code for this one. Notice that I've added all the dependencies with poetry. So when you build your own RDM system, we need to go through all the steps that we discussed in this course. We have our data management plan, and that goes together with the metadata schema that we need to develop. And we need to implement that schema in some sort of database. So there we need to think about which database we want to use and where and how we want to deploy it. Then we need to fill the database with appropriate values. We have maybe external data that we want to extract metadata from. We need to store our files somewhere, and in the end build a little web GUI. So putting everything together will build you your own little RDM system. Let's start with the metadata schema. First of all, create a data management plan, and then based on that devise your own metadata schema for the research project you're working on. And then think about the technology choices in databases. Which database do you want to use? Where do you want to host the database? For this project you can use PostgreSQL as a relational database. It's a powerful SQL database that can be used in production. You can use others, of course, but this one scales up to quite a large production environment as well. You can host it yourself on a server that you would have, or you can use an external database hosting service as you like. And once you've settled on a database technology, and if you use a relational database, prepare the schema and prepare the database, connect to the database, write usable SQL code, for example. Ideally use a coding IDE and use Git to manage your code. There are some examples in the code repository that work with PostgreSQL. You will also need to extract metadata. For example, if you have some files that come out of your scientific instruments, you will need to decode and extract metadata from them. So write some code to extract metadata automatically from your data files. Likely you have a lot of proprietary data formats, so that means you would have to reverse engineer. Those are most relevant for you. I put some examples in the repository as well. As file storage, you need to think about where you're going to store the files, and one idea is to use the S3 object store. So get familiar with that, try to upload files, check if files exist already. I've already added some demos as well. And finally, you need to bring everything together, right? The user doesn't want to interact with the S3 storage themselves and with the database directly, so you need to build a front end for them, our little web app. So this is what users will use to interact with your own RDM system. So, for example, you could list the current contents of the RDM system, add new samples and storage location, upload files to an S3 object store, extract metadata and so on. My suggestion would be to use Streamlit and Python, and this is a library for easy app development and deployment of web apps. It's good for small apps and prototyping. If you're actually going to build your own system, you will probably need a more elaborate framework, but it's good to get started, and I've put some little demos there as well. And now we have a few pointers of how to build a very basic system. However, there's a long list of things that we didn't implement so far, but you need to think about when you want to implement or deploy an RDM system. So we will have to have some sort of user right management and access right management, so that not everyone can connect to our RDM system and add stuff or delete everything. You will also have to have some sort of sample management, for example via QR codes, so you need some way of generating QR codes and to print them and so on. We also need to integrate recipes or standard operating procedures or protocols. We've talked about sharing and publishing data and metadata, and of course that needs to go into the system as well. And since we based this, at least this demo system, on relational data models, we can make use of complex hierarchical relationships, although of course in our very simple project we didn't actually exploit this. Now we have what's more or less called a laboratory information management system. You would want to complement this with an electronic lab notebook with multiple forms and free text entries, adding images and so on. We also need to think about if we want to use controlled vocabulary and how to do data quality checks and automated data workflows beyond what the database engine can do automatically. One way or one benefit of using a relational data model with a defined schema is that the database engine can do a lot of data quality checks automatically already. And then finally we want to use our RDM system, so we need some way of adding data analysis workflows on top. So in principle at least you have all the ingredients even with this little demo system. You just, and it's really a big just in quotations mark, need to implement it. So that's out of scope for our little project, but you can see where the complexity in a real world system comes from, and hopefully implementing such a very simple system gives you an idea of how to make technology choices and difficult decisions about how to deal with data and metadata.